Now we will have example for conversion of regular grammar to finite automata. Okay, so first we will take an example. So this is, suppose consider this is the given grammar and we have to convert this grammar into finite automata. Okay, so let M is equal to Q sigma delta Q0F be a resultant finite automata. So now we have 5 tuples. Okay, we have considered M machine will be the resultant finite automata that will get converted from the given grammar. Okay, so how we can get all these 5 tuple? So first tuple will be Q. So Q here, how we can find out it? So here we have total 1, 2, 3 variables. Okay, and so we have taken here 3 states, that is Q0, Q1, Q2. Out of that, Q0 corresponds to variable S, Q1 corresponds to variable A, and Q2 corresponds to variable B. Okay, so for these 3 variables we have 3 states in Q, and we have to add one extra state that will be a final state. Okay, so that we have to take it explicitly. So we have total 4 states in a resultant finite automata. Okay, so that's why Q set will be Q0, Q1, Q2 and QF. Now we have set of terminals, that is nothing but T. T is equal to what? A and B, means small a and small b will be the terminal. So terminal set will corresponds to set of alphabets, that is nothing but sigma. So the value of sigma or set sigma can be find out from the set of terminals, and set T includes elements A and B. That's why sigma will be A comma B only. Okay. Now next we have to find out the delta transitions, means set of transitions from the given productions by following the 2 rules as we have discussed in the earlier video. Okay, that will find out later. Okay, then next is what? Q0, that is initial state. So in case of regular grammar, start symbol will corresponds to initial state. So here S will act as a start symbol. That's why Q0 state corresponds to S. That's why Q0 will act as a initial state in case of resultant finite automata. Okay, then we have set F and we have considered explicit final state, that is nothing but QF, and that will be the single final state considered in the resultant finite automata. Okay, now we have observed here, or we have got here 1, 2, 3, 4 tuples of the resultant finite automata, and now we have only one tuple, that is delta remaining. Okay, so we will find out it by following the rules of conversion method. Okay, so if we have productions of the form AI tends to small aj, that will be converted into delta of qi comma a is equal to qj. Okay, so instead of this production we can write this transition, and if we have the productions of the form ak tends to small a, that will be converted into delta of qk comma a is equal to qf, and here qf will act as a final state. Okay, so we will follow these 2 rules to find out or to convert the given productions into the transitions. Okay, so first we will consider the first production, that is S tends to small a. Okay, so that will be rewritten as delta of S is the start symbol, and for S we have in corresponding state, that is Q0. So instead of S I'll write here Q0. Okay, so input symbol will be A now, because here we have terminal A is equal to output variable is A, and for A we have corresponding variable, that is Q1. So output state will be Q1 only. Okay, so we have converted this production in this format. Okay, so it follows the first rule, that is AI tends to small a aj. Okay, now we will take the next production, that is second is S tends to b. Okay, so delta of, now instead of S we will have q0 comma input symbol is B is equal to output symbol is B. Instead of B we have corresponding state as q2. Okay, so this will be the final transition. Okay, now third, next production is A tends to small as. Okay, so delta of A, instead of A I'll put q1. Okay, q1 comma A is equal to S. Instead of S I'll put q0. Okay, now the next production is A tends to small a. Okay, so this will follow the second rule, that is AK tends to A. If we have production of the form AK tends to A, then that will be converted into QK comma A is equal to QF. Here we have to take explicit final state, that is QF. Okay, so again here we have to take QF as a final state. Okay, so that will be converted like delta of A, instead of A I'll write Q1 comma A is equal to QF, and QF is the final state. Okay, now next transition, so B tends to small b s. Okay, so that will be converted as, instead of B I have q2. Okay, q2 comma B is equal to S. Instead of S I have q0. Okay, now next sixth and the last production is B tends to small b. Okay, so this will follow the second rule. Okay, so that will result the transition B. Instead of B I can write q2 comma B is equal to QF. Okay, so here we have got a set of transitions, that is delta. Okay, so I have listed here all the resultant transitions of the finite automata. Okay, so here we have got set Q, then we have sigma, then delta, then Q0 and F. Okay, so means what, we have M and we have find out all the tuples of the finite automata. Okay, that are resulted from the given regular grammar. Okay, so hope so you have understood this video and the method of conversion of grammar to finite automata.